Hello students, welcome back to the new series, that is ISRO exam series. In this series, we are going to discuss a subject called measurements. So this is a allied topic for electronic and electronic engineering students. Actually measurements is a electrical concept, okay, electrical engineering subject. Now let's start with a simple basic relevant topic which is important for any competitive exam, okay, in measurements. Then we'll solve some problems in that exam, in that concept, okay. Now let's start with that one. The first let's discuss the topic name is loading effect. Topic name is loading effect. So if you check with the topic name loading effect, so what happens if we load the any system, or suppose in a simple example, let's discuss a simple circuit example like this. I have a voltage source of some 100 volts. I have a resistance connected to this voltage source of, let me take it as 10 ohm. Now I close this circuit by using some additional wire like this. So I have to measure the current flowing through this one. So I need to find the current flowing through this wire. So this is the question. So how you will measure the current usually? If you take the measurements concept, or if you understand how you will measure the current in any lab, you will use some meters. What is the name of that meter? We call it as a ammeter. Now, so to measure the current, so usually we will find the current. To find the current, we will use different concepts like KCL, KVL, Ohm's law, all those things we will use. But here, this is when we will use this finding technique, when we have a imaginary voltage and imaginary a resistor like this, okay. But this is the finding technique. Here there is no requirement of physical meters. But suppose this is a new question, to measure. Suppose if you want to measure a current flowing through a wire, so what are the things you require? The things required is a voltage source, a resistor and a wire. Along with this one more important thing, that is ammeter. So these many things physically you require to measure the current flowing through the wire. So what is the question here? Here we need to measure the current, that is we need to measure the current flowing through this wire. So what we have to do? We need to connect a ammeter to that wire. So this is a voltage source of 100 volts. This is the 10 ohms. Now this is the current. Here I will connect a ammeter like this. Now what is the meaning of this loading effect? What is the meaning of this loading effect is? So practically no device will be in ideal condition. No device exists in practical as a ideal one. Means, what is the meaning of ideal one? Means it won't have any losses. Yes or not? It won't have any voltage drops. It won't have any power losses. It won't have any energy losses. So these are the ideal conditions. So is there any element which exists practically as a ideal properties? No, not at all. But during the analysis part, or during the calculations part in our theoretical concepts, what we'll do is we'll assume this as a ideal one. We'll usually assume this as a ideal ammeter. So what is the meaning of ideal ammeter? Means no power loss, that is no heat will be produced inside this one. No heat means no power loss. No power loss means no resistance. So these are the things. Means this ammeter will not exhibit any amount of resistance, So because of this one, when we connect this circuit through this ammeter, immediately current will flow through this ammeter like this. So for a generalized concept, what I will do is I will replace these values, physical values, with a generalized values. I will replace these values with a generalized values like this. So source voltage is V and resistor value is R. So what is the amount of current here? How much amount of current will be measured? If it is an ideal one, if it is a ideal ammeter, what is the current you will get? Its value directly depending upon the ratio of voltage to resistance. Ratio of voltage to resistance. So this is the current. Let me take this current as I1. So when we have assumed ammeter is an ideal ammeter, during that time we got the current as V by R, and this current, this is the actual value of current we need to measure. This is the actual value of current we need to measure. That is the reason we call this value, means this is the true current. This is the true current which must flow through this circuit. This is the true value of current which must flow through this circuit, even if you connect a ammeter to the circuit for measuring the current. Okay, so that's why this current is called as a true current. Now let us consider this ammeter as a practical ammeter. Let us consider this ammeter as a practical ammeter. So now let's consider the ammeter as a practical one. What happens to the circuit? Let me see. So this is a resistance, this is a voltage source, and now here we have connected an ammeter, and this ammeter exhibits some resistance. We call that resistance as meter resistance. So now the current will flow through this part. Let me take this as current as I2. How many resistances are connected in the circuit? One is the actual resistance of the system, and another resistance is added inside in this circuit in series with the original resistance. That resistance is your meter resistance. So if I replace this ammeter with its equivalent circuit, so this is the resistance of the system and this is the resistance of your meter, and these two are connected in series or parallel? They are connected in series. Now two resistances are connected in series. What happens to the resultant value? Resultant value is adding these two resistances. So what is the current you will get? The new current value which is measured in this ammeter, which will be equal to ratio of voltage to resistance. So previously, how many resistances are there in this circuit? In the total circuit you have only one resistance, but in this new circuit how many resistances are connected? Two resistances. How they are connected? Series. So because of the series connection of resistances, what happens to the resistance value? Is it increases or decreases? Resistance will increase. Because of the increment in resistance, current will goes down. So during the series condition means you need to add both the resistances. We need to add both the resistances. So this is the this is the current which is flowing through the ammeter. This is the new current which is flowing through the ammeter, and because of the connection of your ammeter, the current, the actual current flowing through the ammeter is this one. Actual current flowing through this ammeter is this one. So this is the actual current flowing through the ammeter, flowing through the ammeter, through ammeter. So is there any difference in current in between I1 and I2? Yeah, there is a big difference. See here, I1 is equal to how much? How much? V by R. What about the I2 value? I2 equal to V by R plus Rm. Now here in both the circuits you have V as common. So what I'll do is I'll replace the V with I1 and R. So if I send this to other side, you will get I1 into R as a value of V. So this is R plus Rm. So from this one, what is I2? I2 is equal to I1. I2 equal to I1 by 1 plus Rm by R. Rm by R. Okay. So now when these two values will be equal, when Rm is equal to 0, I2 is equal to I1 when Rm becomes 0, when Rm becomes 0. So if Rm is other than 0 value, means if Rm is a non-zero value, obviously the amount, if Rm is non-zero, if Rm is equal to non-zero, then what happens to the I2 value? I1 by 1 plus some value of this value, whatever it may be. Okay, so if this is non-zero, so this non-zero value is added to 1, so we'll get a more than 1 value, and denominator becomes more than 1, so this denominator value is greater than 1 you will get, so that your I2 becomes less than 1. I2 becomes less than I1. Means the amount of actual current which is measuring by the ammeter is less than the original value of current flowing through the circuit. So because of the ammeter resistance, what is happening? Due to the ammeter resistance only, we are introducing the error into the measurement. Yes or not? So the ammeter resistance is creating some load on the original circuit. That is the reason we call this entire concept as a, how we call this one? Loading effect. Understood or not? So what is the meaning of this loading effect? Means resistance, because of the meter resistance, that too especially ammeter resistance, what happened? The actual value of current measured by the circuit is less than the original value flowing through the circuit. So as there is a less current flowing through the circuit, so you will get less amount of losses in the system. Yes or not? But if you take only one resistance into consideration, but because of the presence of your meter resistance, again the losses will be again differs, because I1 square into R is different value, I2 square into R plus RF, R plus Rm will be different. Yes or not? So like this, you have a loading effect. Means because of the connection of ammeter, what is happening? Physically some load exists, physically some loading a problem is coming to picture. Means the measurement of your current is affected because of the meter resistance. This concept is called as loading effect. See this same concept will discuss with the voltmeter also. Now we have a resistor like this. Otherwise let me take a voltage source like this, and here we have two resistance values. One is R1, another one is R2. Let me take the source voltage as V. Now I need to find the voltage across this R2. That is V2 or V0. Okay, so let me take this as V1. I need to find the value of V1. So how we will find this one? If you want to find the value of voltage here, so how we usually find this value? By using voltage division concept. V1 equal to V into R2 by R1 plus R2. So this is the meaning of finding. Suppose if I want to measure this voltage, how will measure the voltage? By using voltmeter. So if I connect a voltmeter, if you choose this voltmeter as ideal one, voltmeter as ideal one, then your V1 will be equal to same as above, that is R2 by R1 plus R2. So what is the meaning of this one? If I choose this value, this resistance value of your voltmeter is ideal, then what happens? This value, whatever the value we will get or we will measure, that value we call it as a true voltage, true value of voltage, your voltage. Now let's introduce the internal resistance of your voltmeter, then we'll move to the problems. Now let's take the same problem, R1, R2, and now we'll connect the voltmeter, we'll connect the voltmeter. So that voltmeter will have some internal resistance. That voltmeter will have some internal resistance. Let me take this resistance as Rm, meter resistance. Now what happens to this one? What happens? These two are in parallel. So what happens to the resultant one? R2 into Rm divided by R2 plus Rm. So this is the equivalent resistance of this combination, and this resistance must be added to R1 to get the output. Now, so this is the total resistance. How will get the value of your this one voltage value? How will measure this one? That will be equal to the voltage across this entire combination is your new voltage. So what is V2? V2 is equal to V into, what is the equivalent combination here of this one? R2 into Rm by R2 plus Rm. This is the combination voltage by R2 Rm by R2 plus Rm plus what is this value? R1. So if I use this one, this will be your actual value because of the presence of the actual value of voltage. So because of the presence of your meter resistance, because of the existence of meter resistance here, the entire voltage measurement is changing when compared to the ideal voltmeter concept. When it is completely changed, it is completely changed because of the presence or because of the existence of your resistance of your voltmeter. So this is the meaning, this is the effect of your loading effect of loading effect or effect of loading of your ammeter. Means because of the presence or because of the existence of resistance offered by the internal resistance offered by the either voltmeter or commmeter, so that creates the original values of your voltages and currents that depends upon the system to system. So once we know these two concepts, the later concept in this regard is the next one is calculation of percentage error. So what is the percentage error? It will be equal to true value minus actual, sorry. So this value is actual minus actual value minus true value divided by true value. So this is the problem. So because of the presence of your resistance either in ammeter or voltmeter, so the actual value is less than the original value, less than the true value. So because of this one, most of the times this error will be in negative. Always this error will be in negative. Mostly this error will be always negative. Now let's solve some problems regarding this loading effect concept. Okay, let's solve some problems. So this is the problem we have discussed, just now we introduced, and we need to measure the current flowing here. So to measure the current, whatever we discussed, there is a ammeter requirement here. So if I connect an ammeter, so this ammeter you have two cases, one is ideal case, another one is practical case. So if I choose the ideal case, so whatever the current will measure, that current is called as a true current. Whatever the practical ammeter if you choose here, so this practical ammeter, what it will give? It will give you the actual value which is flowing through the current, but which is not equal to the true value, So because of the deviation in between the true value and actual value, because once we introduce the ammeter into the circuit, this ammeter is creating some loading on the source, so that the actual value of current flowing through the circuit will be less than the true value. So because of this deviation, you will get a error in this circuit. So here in this question, first we need to calculate the current, that is true value of current. So this is the first question. Second question what we need to do is we need to calculate the actual value of current. This is the second question, and we need to calculate the percentage error. So these are the three questions we need to solve in this question. Now let's solve first one, actual value, true value of current. So to get the true value of current, we need to introduce the ammeter, and that ammeter internal resistance will be, what is the value of internal resistance? It is 0. So this will be 10 ohm, this will be 100 ohms. So what happens to the current I1, that is true value of current, that is equal to 100 by 10 plus 0. This will become 100 by 10, which is equal to 10 amperes. So this is the true current. What about the actual current? So to get the actual current, we need to introduce the ammeter, which is a practical ammeter we need to introduce. So this practical ammeter is having some internal resistance. Let me take it as 1 ohm. So this is 10 ohms, and this is connected to a source of 100 volts. So what is the measured value of current in this one? So this I2, which is equal to 100 by 10 plus 1, which is equal to 100 by 11. What is the value? You will get it is, I think, 9.09 amperes. Is it correct? 11 9s are 90. So you need to introduce one more point. So 100 by 11, 9.09 amperes. So what is the next question we need to calculate? We need to calculate the value of percentage error. So what is the percentage error in this circuit? The percentage error is equal to the actual value of current minus true value, actual minus true by true value. So this is the thing, multiply with 100. So here 9.09 minus 10 divided by 10. So what you will get? Minus how much you will get? 0.91 into 100 by 10 into 100. So this will become 9.1 percentage. But what is this value? Minus negative value will get. Yes or not? Minus 10. So 9.09 minus 10, minus 0.91 into 10. So we'll get 9.1 percentage error. This is the percentage error in the measurement. Okay. Now let's solve another problem with the help of voltage calculations. That is voltmeter introduction. So what happens if I choose that kind of system? So this is a 10 volts. Here I have 1 kilo ohm, or let me take it as 100 ohms. This will be another 100 ohms. Here I have 50 ohms. So this is the open circuit. Here we need to calculate the current. We need to measure the voltage here. We need to measure this voltage by connecting voltmeter and instead of this one, otherwise we'll do the same thing. Let's measure the current here. Find the current here. So how many currents we need to calculate? First one is true value of current, actual value of current, and percentage error. So these are the things we need to calculate in this circuit also. So to get that one, so the circuit consists of multiple sources, one source with multiple elements. So if I choose this as a black box, so if I replace this entire black box with a single resistor and that resistor we call it as Thevenin's resistance, and with a single voltage source, so that it will be easy for us to solve this problem. So let's solve this one. So if I choose this one, if I open circuit this one, what will get? 100 is connected in series. Because of open circuit, 50 ohms will be isolated. So that what is the Thevenin's voltage here you will get? The Thevenin's voltage will be 5 volts. You will get 5 volts as a Thevenin's voltage. And what about the Thevenin's equivalent resistance? To get the Thevenin's equivalent resistance, I need to It replaces all the voltage sources with its internal resistances, and current sources will also, with all sources will be replaced with its internal resistance. What is the internal resistance for voltage source? It will be 0. So 0 means short circuit. 200 ohms are in parallel, so the resultant become 50. 50 in series with 50, you will get another 100. So this is 100 ohms. So this is the thing. And here we need to connect it to this one, so what happens to this one? How much amount of current is flowing here? What is the true value of current here? The true value of current is equal to how much? 5 by 100. 5 by 100, it is equal to 0.05, that is 50 milliamperes. 50 milliamperes. Now let's calculate the actual value of current by replacing the resistance with its internal ammeter with its internal resistance. So let me take this as 100 ohms, take this as 10 ohms. Here you have 5 volts. So what happens to the new current, that is actual value of current? The actual value of current is equal to 5 by 110, which is equal to how much? What is the value of 5 by 110? So it will be 45.45 milliamperes. So now what is the percentage error? What is the percentage error you will get? It is equal to actual is 45.45 minus true value is 50, minus 50 into 100. So this becomes minus 0.05 divided by 0.05. This will be again equal to minus 9.09, minus 9.09 percentage. So this is how you need to solve these kind of problems. Now let's solve one more problem by taking the voltmeter into consideration. So let me take the 10 ohms, another 10 ohms here, okay, and here let me take it as some 100 volts. So here we need to measure the voltage across this one. This is the place where we need to measure the voltage. So if you want to calculate the true value here, directly I am calculating the values. So what is the true value means? Two equal resistances are connected across at 100 ohms, 100 volts. So that voltage will be divided in equal half, or use the voltage division rule, that is 10 by 10 plus 10, which is equal to 50 volts you will get. So this is the true voltage. What happens to the actual voltage? What happens to the actual voltage means, here you need to connect a voltmeter. So let me take this voltmeter having a internal resistance of 1 kilo ohm. So because of the 1 kilo ohm is connected in parallel, what is the equivalent resistance of this combination, parallel combination? 1k into, what is the resistance of the meter? 10, right? Divided by 1k plus 10. So what is this resistance you will get? This resistance may be some value like this. This is 100 volts, 10 ohms. 1k into 10 divided by 1k plus 10. So this will be equal to 9.9009 kilo ohms. Sorry, ohms. So once we got this one, now let's calculate the voltage across this one. This is actual voltage. So what is the actual voltage? Which is equal to, by using current division, voltage division again, 9.9009 divided by 10 plus 9.9009. So this value becomes how much? 9.9009 divided by 19.009. So this becomes 52.08 multiplied, this becomes 52.085. 52.085. This is volts. Now let's calculate the percentage error. Percentage error is equal to how much? So actual voltage is 52.085 minus 50 divided by 50 into 100, which is equal to 2.085 by 50 into 100. So this becomes 2 times. This becomes minus 50. 2.085 into 2, it will be 4.17 percentage. So this is the percentage error we will get because of the internal resistance offered by the voltmeter. The increment in voltmeter reading means this combination reading is increased from 50 to 52.085. So this is increased by 2 volts, but in the previous case there because of the ammeter resistance, internal resistance, the actual value is less than the true value, but here the actual value is more than the true value. Okay.